Hello, 8th graders. Today's joke of the day is, how did the hipster burn his mouth? Stay tuned to find out. Our learning target for today is, I can identify the domain and range of a relation, and I can identify a function from ordered pairs, a graph, or a table. Okay, so let's start out with some definitions. All right, the domain is the set of all x values, or the set of all inputs. Okay, the set of all inputs or x values. Okay, and then the range is going to be the set of all outputs or y values. Okay, so the domain and the range both play a role in determining whether or not something is a function. Okay, so a function is a relation. Okay, it's a type of relation for which each element of the domain corresponds to exactly one element of the range. Okay, so sometimes the way we say that is each input has only one output. Okay, so if we're thinking of a function like a machine, if you put in, let's say, the number 2, there's only one possible output. There's only one possible answer for the number 2. Okay. So let's practice putting these into play here. We're going to first identify the domain and range of the relations, and then determine whether the relation is a function. Okay, remember our ordered pairs are in the form x, comma, y. Okay, so all of the first numbers are going to be in our domain. So here I'm going to highlight them. So our domain I'm going to highlight in blue. Okay, so it's going to be the first number in each ordered pair. Okay, and you only need to write each number once. Okay, so let's look at this here. Our domain is going to be the set. Okay, we write a little set bracket, and then we'll say 1, 2, 3, and then we have 1 again. So we only list that one time though, and then we'll skip that second one, and then we'll put 4. Okay, and that's our domain, 1, 2, 3, 4. Okay, then our range. Oops. Our range, I'm going to highlight in red here. It's going to be all of our outputs. So we have 2, 5, 1, 6, and 8. And we'll want to list those in order from least to greatest. So we have, let's see, 1, 2, 5, 6, and 8. Okay. And then we have to determine yes or no, is this a function? Well, a function means that every input has only one output. Well, in this case, our domain is actually smaller than our range, and that's because 1 corresponds to 2 and to 6. Okay, so 1 is an element of the domain that actually has 2 outputs, so it is not a function here. Okay, no, not a function. All right, let's look at the next example. Okay, again, I'm going to highlight my domain in blue. So we have 8, 3, 4, 0, and 1. And we'll order them from least to greatest. So I have 0, 1, 3, 4, and 8. Okay. Then our range. All right, we'll do in red again. We have 5, 1, 6, 3, and 2. So I'll write those. I'll do my brackets here. Let's see. We have 1, 2, 3, 5, and 6. All right. In this case now, is it a function? Well, each element of the domain is only listed one time. Okay, so that means they're all only going to have one output. So yes, this is a function. Okay, let's look at an example where our inputs and outputs are in a table. Okay, well, all of our inputs are right here. I'll keep writing them in blue though. Okay, so we have 3, 4, 5, 4 again, and 10. So just 3, 4, 5, and 10. We only list each number one time. And then our range, we have 0, 7, 10, 14, and 25. Okay, and again, our range is bigger again this time than our domain, and that's because 4 here corresponds to 7 and to 14. Okay, so it matches up with more than one element. 4 does. So this case means it's not a function. Oops, let me grab the pen again instead of the highlighter. No, not a function. All right, next example. The domain is all of our inputs. And in this case, we have -1, 0, 1, 2, and 3. And our range is our outputs. Let's see, it looks like we have 3, 4, 5, and 7. Okay, and each time each input only has one output, so it is a function, yes. All right, now let's look at some graphs. Okay, these ones are actually we're not going to be able to list each number in the range or in the domain. We are going to have to write it as an inequality. Okay, so our domain, all of our x's, well, it starts at 2, and then it looks like it's going to cover all the x's going this direction, okay, forever and ever. So our domain is going to be x is less than or equal to 2. Okay, because it starts at 2 on the x-axis. Remember, we have x and we have y. Okay, it starts at 2, and it's going to be all the numbers to the left. X is less than or equal to 2, and all the way down to -infinity. Okay. And then for our range, that's going to be our y values. Well, our y values start at -2 and then go up. Okay, so it's all the ones going up. So it's going to be y is greater than or equal to -2. Okay. And when we have a graph, we can determine that something is a function or not using what we call the vertical line test. Okay, so I can draw a line anywhere on this graph. Okay, and it is going to only cross it one time. So yes, it will be a function. Okay. All right, let's look at one last example here. Now, in this case, we have a bunch of points. So we will have some ordered pairs, and you could do this a couple ways. You could just write out the ordered pairs. Remember, we have x and y here. You could just write out the ordered pairs and then figure out what the x values are. I think that's what I'm going to do. Okay, so our ordered pairs are -3, -4. Let's see, that's this one. And then we have -2, 5. Okay, that's that one. And then we have 1, 3, that's this one. We have 1, -2. And we have 0, or no, we have 4, 0. Okay, so our domain is going to be -3, -2, 1, 1 again, and 4. -3, -2, 1, and 4. We only list one time. Okay, and then our range is going to be all the others, -4, 5, 3, -2, and 0. So let's see, -4, -2, 0, 3, and 5. Okay, and in this case, we have 2 ordered pairs that have the same input, 1 and 3, and 1 and -2. So that means that this is not going to be a function. All right, and now for our joke of the day. How did the hipster burn his mouth? He ate the pizza before it was cool. Thanks for watching, and have a great day.